All right, so we are ready to start session 10 on combining images. We will be setting up Warpy. So to download this extension, you could go to the BIOP GitHub page, and then we're gonna click on the assets and get that zip. Once we have it, we would unzip it. And once this is done, we have those individual 6 jar files. Drag and drop into QuPath, all 6 of them. The QuPath is asking me if I want to use default directory for my extensions. Sure, that's a great choice. Okay. I will now restart QuPath. So if everything worked correctly, under extensions, we should have Warpy. And in analyze, we should have interactive image combiner Warpy. Can I get the thumbs up from the room that we all have it done? And if people that do not have it, if they can raise and hold their hands so we can help you guys out. So while we're waiting for the whole group to get it done, we are gonna just slowly create a project, a brand new project. I'm gonna do it by creating a new folder, calling it session 2, drag and drop it, create projects from empty directory, yes. Okay, now we're gonna have to add 2 files. One of them is called Tonsil flip OME-TIFF, and the other one is called Tonsil H&E. I remember that I have my files in my documents, so I'm just gonna navigate towards that, and I'm gonna drag and drop flip OME. I happen to know that this is a fluorescence image, but actually, you know, I'm gonna show you one little neat trick that that I sometimes use. I'm gonna go to my settings, and I'm gonna search for brightness. In the viewer, I have this auto brightness and contrast saturation %. I'm gonna make this a smaller number. I'm gonna go 0.005%. Okay, and this is helpful when you're working with those multiplex files. Oftentimes, this is gonna create or this is gonna open the file in a way where those images are less saturated. It's gonna take just a moment to populate my image list. That's fine. We're just gonna be patient and wait for it to read. So because I have this console opened, I can see what's going on here. Not much. Okay. Well, looks like my QuPath crashed, so I'm just gonna start over. Yeah, okay. It managed to figure it out. It just took a little extra time. I'll do the same with my Tonsil H&E image and just drag it and drop it here. And I happen to know that this image is an H&E, so I will use that. Okay, and then we're gonna wait a little bit until everybody got those two images set up in their project as I have right here. Yes, when you're changing the preferences here, you just type in a number and then you close it. It's not going to affect any images that you've already have added to the project, but any new image that you're going to drag in is going to take that into account. So I'm just going to wait for a couple, for a little bit longer. And in the meantime, we can browse this, this file a little bit and take a look at what we have. So this is a piece of human tonsil. I just enabled the first three channels. I'm just going to change hex to something like maybe white. Okay. Adjust it a little bit. By the way, if you're changing your channel max and it doesn't want to go, you just click on that number and then you can type a bigger number. So we're going to be spending quite some time today looking at those interesting cells inside this B cell follicle. These cells have C11C and CD68 on them. And they are called tangential body macrophages. They eat apoptotic B cells. Can I get a thumbs up from everyone who has their project set up in such a way that they have Tonsil, Flip OME-TIFF, and Tonsil H&E? Okay, can you just hold your hand so I can see who doesn't have it? Okay, so now put them down, please. And everyone who doesn't have a project set up this way, please raise your hand. Okay? Well, we'll take some time to catch up. So I can now click on Tonsil H&E. I will save my changes, and I'll just take a look at it, giving all of us a little bit extra time to figure it out. So this particular H&E image has been acquired after we did the immunofluorescence run on it.
You should have to increase the memory because a couple of people seem to need that.
I think you will have to help me with that. Please do.
Hello. Okay. If either you're getting a too big of a tile cache error or you're trying to open the image and it's just circling forever and not going anywhere, thank you. You can increase the amount of your computer's memory that is dedicated to QuPath. So click on the cog here for settings. Go to General. And then your max, this is a 32, you don't know. This is probably a 32-bit. Okay, by default, it's going to request 50% of your total memory. I would actually change that to 75%. Sorry, I heard a big ooh. It's like, I'm going to change that to 24. And then percentage for tile caching, I'm going to change to 50. And then this error pops up right here. Well, not an error, just a warning that you have to then close QuPath and reopen it. You don't have the max memory option? Okay, then just change your tile caching. You don't have it like right above?
It's a mag.
Okay, well, cool. then whatever your max memory is what it is, but increase your percent fertile caching to, yeah, try 50. And then restart QuPath. Only if you're getting errors. The file's a little bit large. Even on my version.
So I'm going to take this couple seconds more to tell you about an ideal setup for QuPath, and that's definitely not going to be your laptop computer. You can run it on a laptop, but you want a lot of memory, you want a lot of storage, you want quite substantial processing power, and you definitely want a bigger monitor. And you very much like to have a mouse. Okay, those of you, I know this is not an ideal room for doing those kind of exercises, but those of you who are working on a trackpad, your life quality is going to improve drastically once you get a comfortable mouse. But it's all about visualizing and seeing things, right? So doing this on a very small screen is very, very difficult. Once you switch to larger screen with more resolution, things are going to be a lot easier. Anyone who does not have a Tonsil-H&E open under QuPath, please raise your hand and hold it. We're ready to go. Okay, so our instructions tell us that we will first do so-called stain deconvolution. This is an RGB image. It's kind of a true color image, and we're going to try to make it a little bit more user-friendly for computers by instructing QuPath and telling it what is the hematoxylin, or the nuclear channel, the blue stuff, and what is the eosin, the channel that is associated with protein stain in cells and generally stains proteins. And just before we start there, I'm going to show you that when you're working with those RGB images, oftentimes changing gamma can help you to better visualize different aspects of your sample. Gamma is a nonlinear adjustment. You need to report it if you're using it for your images, but it makes it look a little bit more like you would look at that sample when you're looking at it under the microscope itself. So what we need to do is we need to find a region where you have some nuclei, where you have some eosin-rich cells, and you also have some empty pixels belonging to the background. And what we're going to do is we're going to create a relatively small rectangular annotation, such as this, where I have all three classes of those pixels: some background, some eosin. Erythrocytes are a good example of structures that are only filled with eosin stain, and some nuclei stained with hematoxylin, like here. It's very important that if you don't have your image type set to Brightfield H&E, you should. So you can double-click here and set it to Brightfield H&E if that is not what's showing on your image tab in your project. Once you have this and it is selected, let's go to Analyze and Estimate Stain Vectors. Analyze, Estimate Stain Vectors. Click that, and QuPath is going to ask you if you want to use the model RGB values for your background. Say yes. And then you're going to have this visual stain editor. That is a tool that allows you to separate this three-color RGB image into hematoxylin and eosin channels. If you're more interested in that, we have lots of content on that on YouTube in our 2023 edition of From Samples to Knowledge. I'm gonna go ahead and use recommended settings from GitHub, max total OD to 2, and then press the auto button. And automatically QuPath found the stain vectors. I'm gonna leave the name of stain vectors as default. And now if I press 1, I'm gonna get this original image. If I press number 2 on my keyboard, I got the estimated hematoxylin stain. If I press 3 on my keyboard, I get estimated eosin stain. Yes. What? The question is, what happens if you don't do this? You will not be successful with running this particular workflow that we're doing right now. QuPath auto-estimated the stain vectors based on that image type that you've selected. So you may be okay running it, but it's not ideal. Okay, so now we're going to delete that small box. And I have a very complicated set of classes over here, so I'm just gonna reset to default. And then I'm gonna right-click on that image, go grid size 1:2, horizontal. I'm going to save this image. And now I have 2 viewers. I have 2 parts of my screen. And I can have my H&E image in one of them, and I can add my fluorescence image in the other.
Right now, I'm gonna make a pre-pyramided one and pass that around. I'll also make a much smaller plot that won't work for session 10, but will work for session 1.
So I want to double click, sorry, I want to click on that image right here, on that viewer, and then I just double clicked on that OME-TIFF file. Zoom people, I'm sorry, we're having a lot of issues with the folks inside the room, so we're going to try to get to your questions, but not right now. And I probably made a mistake of not updating this computer while it wanted to do that. Because sometimes this is one of the reasons why things are working extremely slow on Windows, like in my case. Okay, but we've managed to get an image open in the other viewer. How many of you have something that I have on the screen? Okay.
Some people still have the script open from previously that shows the channel names, and it might still show something like hooks or whatever. Make sure to close that script before you do any of this. Apparently, it's locking some of the settings in and trying to read some of the fluorescence settings, even if you have everything set up correctly otherwise. So yeah, make sure to double click on that little floating control and close it.
And when in doubt, just restart QuPath. Okay, so what I'm going to do now is I'm going to change this image so that it looks similar to our H&E image. I'm going to right-click and unsynchronize my viewers. And I'm going to click here. I'm going to set the viewer gamma back to 1. And I'm going to uncheck all of the channels. I'm going to select Hext and select autofluorescence 1. I'm going to change Hext to something that resembles my hematoxylin. And I'm going to change my AF1 to something that resembles eosin. And then I'm going to click Invert Background. So with a little bit of extra TLC, we can actually get them to look even closer to each other. Sure. So I will first save those settings so that I can return back to normal and kind of show you what I've done. Okay, so normally we look at those fluorescence images with a background that's not inverted. In order to create an image that looks like H&E from our immunofluorescence, we can use Hext or DNA channel that's going to be similar to our hematoxylin. And I select a color that resembles hematoxylin in the other image. And then I'm also going to choose autofluorescence, and that has pretty good correspondence to the to the eosin that we have in the other channel. And I'm going to choose something that looks like pink to match what I have on the other image. And then I'm going to click Invert Background. Once this is done, I'm going to save those settings. I'm going to call them Pseudo-H&E and hit OK.
You also change the gamma?
So because right now those channels seem to be linked. So if I change gamma in one viewer, it changes it in the other viewer. I like to use gamma when I'm working with Brightfield images a lot, but I particularly don't like it for the fluorescence. That's my just preference. So I just kind of naturally switched it back to 1. I don't think it matters for what we're doing right now that much. Okay, how many of us have Pseudo-H&E settings? That is looking pretty good. That is looking pretty good. We're going to move forward. So we're going to make sure that we click on this image that was originally our fluorescence image. And then we'll click on Analyze and Interactive Image Combiner Warpy. A new window will open, and we're going to have the image that was selected, which was the immunofluorescence image, already added to that list. And then I'm going to choose Images from Project, click that, and select Tonsil H&E. Then I'm going to click OK. So now I have 2 images that are sitting over here. Okay, so if I click on this image, the Tonsil H&E, it's actually going to be shown kind of overlaid on my IF image. I'm going to change the opacity to about 50% so I can better see how they are aligned. And they're not aligned particularly well. Part of the reason is that the H&E image was taken on a Brightfield slide scanner with much smaller pixel size, where we have more resolution, let's say. And in order to fix that problem, I'm going to need to make some changes to this matrix that is down here below. So you can follow the math that has been done in the GitHub. I warn you, that math is terrible. How many of you know how to do divisions? Ooh, oh, you were talking to math professionals. Okay, no, seriously, it's 0.325 divided by 0.22, and that gives us a number of 1.476. And we're gonna replace the ones with 1.476. Four, seven, six. 7, 6. 4, 7, 6. And that is it. And then what I need to do is I need to click update. Okay, something changed on my screen. Those images are now much more similar in their scaling factor. Okay, now if I move this, I move both of my images. What I actually want to do is I want to hold my shift. I'm holding my shift, and then I can shift one of those images against the other. And you will notice that at some point they kind of match together, right? Far away, now I see double. I'm coming closer, I'm getting there pretty close. I went too far, coming back. That's looking pretty good. That still looks a little uncomfortable. I still see like I've had too many glasses of wine yesterday. So I'm gonna hold my shift and I'm gonna just try to approximate it as nicely as I can. And you know, those blood vessels, those structures that are kind of clearly visible, those are the easiest to match. You will notice that you can only align it nicely in one part of the image, but when you move to another part of the image, that stuff is not going to be aligned as perfectly. And that's because we not only have translation, but we also have rotation between those images. That is okay. We just need to get them more or less approximately aligned. How many of you have that working? We're gonna wait just a little bit more to make sure that everybody got a chance.
Not been able to load the tonsil flip dialog either. Roll.
Okay, we're gonna click on the estimate transform, but before we do that, let's change the pixel size to 10. What's gonna happen right now is that the software will try to align our images using the Affine Transform, and it's gonna be basing that on image intensity. It's one of the reasons why we kind of converted those images and made them look alike, so that function can now work. Click Estimate Transform, and it's gonna take a little while until that is calculated on your system. It may take a while. So I got some updated numbers here. And the instructions say that we want to zoom in on an area with a few nuclei, and we want to further align it by holding Shift and dragging that image around. Okay. I think I actually did a little bit better job than the alignment software itself. Now we're going to refine it. We're going to change pixel size to 2. And click Estimate Transform. And that's going to be a lot more time consuming, potentially. You want to announce something?
Yes. So if anyone is having trouble finding their image while they're trying to overlay things, you can click into the particular window where you lost your image, and then click on the 100% zoom button. Just make sure to uncheck it if you want to zoom in again, but that should recenter the image on that screen.
Just to demonstrate that, that's how it works. Uncheck it, and you can zoom in more. And I'm now going to be adjusting the opacity slider, and I go between one and the other image. And you see that this alignment is pretty good, but there's still room for improvement. They're almost next to each other. So it might be the point where you're going to say, this is good enough for me, because my computer took a very long time to get to that point. If that's the case, this is fine. You can leave it at this. I'm going to click on, I'm going to change the pixel size to 1 and estimate the transform again. Each time you do this, this transformation matrix is going to get new numbers. And whether you are able to run it or not, and now it's still kind of, it's still busy in my case. Now I run it with 1, and I'm getting a pretty good alignment between those images. You may notice that the nuclei look a little bit different. They're maybe a little bit they're in a little bit different spots, but more or less, this actually is pretty close for most of them. If you cannot run it because of your computer, you can go to the GitHub and copy that information that's shown right here. And you can just type this inside your matrix right here. Okay, so this would be here, this would be here, and so on and so forth. And yes.
Let it run. That, or would you see that you could manually put like a small bit to make it even better?
I would. So the question is whether you would like to, should you resist the urge to tweak it manually? And the answer is yes, you should resist the urge to tweak it manually, because what you're going to be doing is you're going to be affecting translation, but you're not going to be affecting rotation or other elastic changes in the file.
get this, I went down to 0.5. And if your computer can handle it, great. But you're not going to actually be better than the computer. Not.
And you can always find local areas possibly because there's variation from tissue to tissue. It's not perfectly flat. So just because you find one area where you can match better than the computer, you might be throwing off all the rest of the image. Oh yeah, yeah. This is a global optimization, whereas you're usually just looking with your cells.
And the note in the GitHub says that if you once you get this this transform matrix, it's a good practice to copy it into a text file and save it. That might be useful for future more advanced analysis when you're going to be transferring objects from one image to another. Yes, if your computer crashes in the next step and you have those numbers copied into a notepad, that's going to be pretty helpful. So I'm going to listen to that advice and I'm going to do it as well.
Can I have the microphone because this is actually important?
Yes.
Importantly, this is not 2 consecutive slides. This is the same slide. We did the fluorescence, and then we did H&E on top. If you're doing 2 consecutive slides, you will never match nuclei to nuclei like that. It's just impossible.
And while this image is taken from the same physical slide, it's not pixel to pixel identical because, you know, you had to run an H&E stain on it. And that involves some steps of dehydration and, you know, you do different things to your sample depending on the details of your staining procedure, but it's not going to be pixel to pixel ideal between your immunofluorescence and your H&E. I think the theme that should come out of this is that all of this is very non-perfect. We live in an extremely non-perfect world, and we're going to have to accept that, you know, those results are going to be very good, but they're not going to be ideal. And yeah, you can live very satisfied life with achieving, you know, 99% perfection. It's going to be good enough. Gonna save that.
Like say a consecutive section or another section. What do you look for when you're trying to align those two images together?
General large features. Blood vessels is a good one because they tend to always be
Sure.
So the question was about what to look for if you are trying to align consecutive sections. And the answer is like general large anatomic features. Blood vessels is good if you have something like pancreatic islets or anything, bronchioles or anything like that. But literally the same nuclei won't be in the same slide, so you can't expect to ever match cells.
Thank you. Okay, so now we're going to click the Create button. And I will say yes. It's going to add another combined image to our project. I think I can now safely close this. I'm going to right-click here, close that viewer. And I'm going to click here and set grid size to 1 by 1. I'm just going to get single viewer. And now I have this another image that was created here that is called overlay. I double click that and open it. This is actually the overlay between my 2 images. And now if I click here into the channel list.
Good example, but
I missed a step. Yes. Oh, I didn't do bicubic. Okay. Yes, I missed a step. So it was very good that I did save my matrix. See, I didn't plan this. I'm just not perfect. And it's still going to work. Let's hope. OK, so let's go back and recreate the steps. I'm going to go to this, go to Analyze Interactive Image Combined Warpy, choose Images for Project, get the H&E, click on that. I'm going to replace that matrix with a matrix that I saved in this file. Can I click Update? Right now, I should have a pretty good alignment. Click all channels in that image. And in the interpolation mode, go to Be Cubic. And click on Create. In the brightness and contrast. And it's important that you select all channels, otherwise those are not going to be combined. So now it switched me automatically to that tonsil flip TIFF overlay, that last one. And now I have all of my channels from, I'm just going to close this so I'm just going to close this so it doesn't get in the way. Now I have all of my channels from my fluorescence image, but I also have channels that formed my my H&E image, the red, green, blue, hematoxylin, eosin. They look a little weird, partially because the settings are slightly different because of that contrast setting that they changed in my preferences. So if I reset them to 0 to max, they're going to be looking more like an H&E image. And importantly, now we can kind of take a look at, let's say CD45 aligned over our H&E image. Or KS67 aligned over our H&E image. Or ecadherin aligned over our H&E image. And just to check the quality of our alignment, let's take a look at the hematoxylin channel that we got from our H&E image. And I'm going to change its color to green. And hex channel that denotes the DNA that we've labeled in our fluorescence image. And I'm going to flip this to magenta. And now I might need to play a little bit with those settings, but in order to kind of create a better visual overlap. But pixels that are strongly overlapping in those two channels, they should give me white image. And I don't want to go too deeply into like the weirdness of that image, because this is a 32-bit floating point image, and that's a 16-bit. So those numbers make very little sense right now, because Some of them are negative and they go only around 0, and some of them are spread from 0 to 65,000. If you're interested in more in that, the 2023 edition focused a lot more on Brightfield images. So you have a compendium of knowledge in those videos and files. My conclusion from this is that it actually performed a pretty good alignment. My H&E based hematoxylin stain and my DNA stain from my immunofluorescence work pretty well, and they are pretty well aligned. How many of you are very confused at this moment? Excellent. That's exactly what I wanted to achieve. So I'm going to tell you why this is useful, okay? Sometimes you may want to have a fluorescence image and you want to maximize the amount of information that you can get from it. The whole pathology was built with H&E images and different kinds of classical histological stains. So by taking your fluorescence image first and on the same slide, creating an H&E slide on the top of that, or creating some collagen staining on the top of that, you can maximize the amount of information you can harvest from that sample. Needs to be done on the same slide if you want to make your life easy. Because only doing this on the exactly same slide gives you the ability to look at the same actual cell. If you're skipping between the slides and you're looking at adjacent section, in the best case scenario, that section is going to be 5 microns away from the previous section. And in the more realistic scenario, it's going to be about 10 microns away. So you're essentially going to be looking either at the next fragment of the same cell, but most commonly at the next cell. So this is, yes. Any more general questions? Why this is useful? For example, you may want to see, you're working on a tumor sample and you're very interested in collagen. And the fact that collagen might provide a barrier for your T cells to go into that tumor and kill it. And you have a staining for your T cells, but you don't have staining for collagen within the immunofluorescence image. You can stain for collagen afterwards using classical histological stains. And now you can combine that information, and you can, for example, get a distance from your tumor-infiltrating immune cells to collagen fibers. Or you just want to take advantage of all of the knowledge that's out in the field, and you want to talk to pathologists, and you will show them that your immunofluorescence image, and they will be like, sorry, what is that? Show me a good H&E, and I can tell you what this is. Well, now you can do it, and you would be able to ask them, for example, to annotate those follicles, which we, by the way, will be doing in the next stage. And this way you can kind of breach and have the language that is common for pathology and for immunofluorescence in image analysis.
Copy and paste and then hit enter, or is there something else?
So the question was, if you are starting from an image, combiner, and you kind of need to recreate your steps, you would be pasting in that transformation matrix, and then you'll hit the update button. And the interpolation mode is bicubic, yes. Okay, so this image that we just created is a kind of a virtual image. It's not yet saved to your hard drive. It's just a combination of information that exists in the immunofluorescence and a combination of information that exists in your RGB H&E image. And that thing is kind of just virtually shown on the screen. It is very useful, but it is pretty slow. So if you would like to export that for future work, you can do it through File, Export Images, and Export OME-TIFF file. It's gonna take some time. I would choose the default settings. Yes, don't do that on your computers because it's going to take quite some time. And it's going to be a big image. So this is just for demonstration purposes, okay? But this is how you can save your image. This stuff only exists in your project. It's not actually written to your hard drive. Okay. And that concludes this, so far, most confusing session of our workshop. I will be happy to take any questions.
You need the most common like EAS, right?
Could you repeat that question, please?
So, so this works for H&E stained images, but what about other histologic images like PAS or Masson trichrome?
Works exactly the same way. The image combiner doesn't really care about this that much. I guess it's important in terms of finding structures that you can relate to each other. So if you, I guess looking at those empty spaces or blood vessels or some structures that are visible in both types of images would be important. But from the perspective of the math, it doesn't actually matter. And the workflow will be very similar. If you have, let's say, PSR fast green staining, you would probably want to separate the PSR and the fast green component so you can have them kind of available as additional channels in your final file. That would be make the most, yeah. Yes, Sarah, could you transfer the mic?
Sorry, who?
So in case my multiplex staining protocol is working by just staining for one color, and then I'm using a stripping buffer, I'm adding the next color and so on. So I do like a sequential staining. Is this the method to overlay all my single colors with QuPath, or
Sarah
would you use
the
another
person to answer that?
approach?
Yes. Basically, yes.
Sarah.
Unfortunately, you have to do it.
Sarah.
Okay.
Sorry.
So yes, if you've got like a cyclical fluorescence or cyclical DAB, this is the method. Unfortunately, you have to do it one pair at a time. So like you'd add 1 and 2, and then add 3 to that, and then add 4 to that, and it can be painful. There's scripts on the forum written by me and Mike to do that in a bit more of an automated fashion. And if some of my collaborators would ever submit the paper that has been sitting on their desk for 6 months, there'll be a paper about it.
Any other questions? Okay. You have officially survived the most confusing session of this workshop. Congratulations.
If anyone's computer is like really struggling with that H&E, with that tonsil flip image, I made a smaller crop. That might be better for the next session. Just let me know. Say about something like tonsil small.